Welcome to Maths and Science by IITian channel. In this lecture, we will be taking up the matrices of complex plane. In that, we will be taking up about the conjugate numbers, and we will be taking up Hermitian matrices and a typical type of Hermitian matrices which are called unitary matrices. This is for higher mathematics classes involving complex plane and complex numbers and conjugate numbers, and these will be useful for IIT JEE and higher mathematics enthusiastic examinations like Maths Olympiad. Now we will go into the details. We know very well, in a complex plane, if z is a complex number x plus iy, then z bar is equal to conjugate of that number, z bar is equal to x minus iy. And this is the first one. Second, we know that if A is equal to a square matrix, then A transpose is equal to, the columns and rows are interchanged. For example, if A is equal to A, B, C, D, then A transpose is equal to A, C, B, D. This much you are already aware. Now, a Hermitian matrix is a square matrix such that Hermitian matrix denoted by A, Hermitian is denoted by like this, plus sign with vertical extended downwards, A plus, or this Hermitian matrix is a Hermitian matrix is defined if a square matrix is such that the conjugate transpose is equal to A, then that is defined as the Hermitian matrix. Hermitian matrix is A plus is equal to A if A conjugate transpose is equal to A. Hermitian matrix is defined as a conjugate of the matrix and its transpose is equal to A, then that A is called as Hermitian matrix. What is the conjugate transpose? Transpose is represented by A plus sign like this. It is conjugate transpose. If this is equal to A, if A is equal to A conjugate transpose, then A is equal to Hermitian matrix. If a matrix is given and asked to find out whether it is a Hermitian matrix or not, we have to follow these steps. With example, I will explain you. Let us take one example. for Hermitian matrix. Example 3 4 minus I 4 plus I and 5. This is a matrix A is given to you. Question is, find whether this matrix is Hermitian. When you know the definition of Hermitian, then only you will be able to find out whether it is a Hermitian matrix or not. Solution. First you have to find out the conjugate. Conjugate of a real number is a real number itself. Please make a note. Conjugate of real number is equal to real number itself. Conjugate of A plus IB is equal to A minus IB. These two things you should know. Once you know these things, then for 4 plus I, the conjugate is 4 minus I. For 4 minus I, the conjugate is 4 plus I. Then conjugate of A. What is the conjugate of A? That is A bar. A bar is equal to, you replace these numbers with conjugate numbers in the elements. 3 conjugate is 3, 4 plus I conjugate is 4 minus I, and 4 minus I conjugate is 4 plus I, and 5 conjugate is 5. This is conjugate matrix. Conjugate matrix. Then what is the transpose of conjugate? Transpose of conjugate is, the rows will become columns and columns will become row. This is the first row. This is the second row. First row will become first column. That is 3, 4 minus I. Second row will become second column. That is 4 plus I into and 5. That is nothing but the given matrix A. That means A conjugate transpose is equal to A, which implies A is equal to Hermitian. A matrix can be called as a skew-Hermitian matrix when negative of conjugate of that matrix transpose is equal to A itself. Then it is called as skew-Hermitian matrix. With example, we will see. Let B is equal to a matrix 0 minus 5 plus I, 5 plus I, 0. Then what is the conjugate of this? 0 is a real number, 0, 0, 0, 0 will not change. 5 plus I is, it becomes 5 minus I. Conjugate of it is. And minus 5 plus I becomes minus 5 minus I, and transpose of the conjugate is equal to 0 minus 5 minus I, 5 minus I, 0. Then negative of transpose of conjugate is equal to minus of this value, that is minus 0 is 0, minus of minus 5 minus I is equal to 5 plus I, minus of minus 5 minus I is minus 5 plus I, 0 is 0. This is nothing but B. That means one, if A is equal to conjugate transpose of conjugate A, that is equal to transpose of conjugate, then A is Hermitian. Please understand this. If A is equal to, that is minus of transpose of conjugate, then A is equal to skew-Hermitian. Now we know what is Hermitian and what is skew-Hermitian, and how to find out whether a particular matrix is a Hermitian or a skew-Hermitian. And one thing to be noted here, I have already explained about the eigenvalues. Eigenvalues of Hermitian are real. Second, eigenvalues of skew-Hermitian are either purely imaginary or 0. Either purely imaginary or 0. This is the homework for you. Please prove these two theorems. I have given you examples of Hermitian matrix. Find the eigenvalues of that. I have given the example of skew-Hermitian. Find the eigenvalues of it and see for a Hermitian matrix whether eigenvalues are real or not, and see whether the eigenvalues of skew-Hermitian are imaginary or 0. Then another matrix in complex plane we want to define, that is unitary matrix. If u plus u is equal to u plus is equal to I, then u is equal to unitary matrix. Or else we can expand this way, u conjugate transpose into u is equal to u into u conjugate transpose is equal to u, then u is equal to unitary matrix. example we will take it as, which example can we take? U is equal to half into 1 by root 2 into 1i I1 and U conjugate transpose will be 1 by root 2 into 1 minus I minus I1, because 1 does not change. Then check for if U plus is equal to I or not. This is for your homework. Please do it. This is the definition. This is the example. Please check it. Now, we have defined some good matrices in complex plane. One is Hermitian, second is skew-Hermitian, and third is unitary matrix along with examples. Hermitian is A is equal to A conjugate transpose, A is equal to minus A conjugate transpose, U conjugate transpose is equal to U conjugate transpose U, that is equal to I, where U is the unitary matrix, A is the Hermitian matrix, and A is the, in the second one, A is the skew-Hermitian matrix. These three you please remember, and whenever any question is asked on the properties of these, you can easily answer them, or any question comes whether it is a Hermitian matrix or a skew-Hermitian matrix, whether it is a unitary matrix, whether it is not a unitary matrix, please check them and solve the examination questions. If this video has added any addition to your knowledge, please subscribe to my channel Maths and Science by IITian, and please share this video to the needy and also to all the colleagues and friends whom you know, and best of luck to all of you for your examinations and your knowledge sharing and your knowledge upgradation. Thank you for listening to me. Thank you for viewing my lecture. Best of luck.